So first of all, my name is Paolo Salvatore. I'm the European member of the Windows Azure Customer Advisory Team. So as the name suggests, our main focus is Windows Azure, and especially Windows Azure AppFabric. So I was formerly in a structure called a Vista Customer Advisory Team. So as some of you probably know, I have a certain background of Vista. Okay. So tomorrow I will show you how to integrate the service bus messaging, so topics and queues with Vista Server. Hopefully, if we manage to make the connection to work tonight using the mobile connection that Jonas is going to provide me. So in this session, we are going to talk about caching, but we are going to see a very specific scenario. So of course, caching is an integral part of our strategy, both on premises and in the cloud. And if you're making an extensive usage of Windows Server AppFabric caching on premises and Windows Azure AppFabric caching in the cloud, you can really increase the number of concurrent users that your application can serve at the same time, of course. So you can really speed up speed up your application, okay? So today we are going to see some techniques that you can use to transparently inject caching capabilities both on the receive side and on the send side into existing WCF-enabled applications, okay? So in other words, you will see some techniques that you can use to rely on Windows Server AppFabric caching and Windows Azure AppFabric caching, okay, but without, rewriting the code of the application, okay? So first of all, let's start with a brief introduction of Windows Server AppFabric caching and Windows Azure AppFabric caching for those of you that don't know this technology. So AppFabric caching was released for the first time as part of Windows Server AppFabric, okay? So it's an explicit distributed cache that you can use, to accelerate the access to frequently access data, like, for example, sessions or lookup data, okay? How it works? From a client perspective, you are just using an API. So it's just a matter of, you can consider the cache, okay, from a client perspective like a sort of dictionary. So you are using methods like get to get an item from the cache and put to put an item in the distributed cache. So indeed, when you install and configure AppFabric caching on premises, you can really create a farm so that the caching, the cache in this case is distributed across various cache nodes, and you can use PowerShell commandlets, okay, to administer the entire environment. But when you are using AppFabric caching in the cloud instead, you don't, of course, you are not using any PowerShell commandlets to manage the entire environment. You are just creating your cache using the Windows Azure Management Portal. Okay, I will show you how you can do that. The on-premises and cloud version of caching are based on the same bits. There are some differences between the two. So on the on-premise version, we provide a possibility to configure secondary copies for high availability. This feature is not available at the moment in the cloud. It will be in the future. You cannot create named caches. You cannot create regions. So at the moment, in Azure, you can just create and use the default cache. Another thing that is not available in the Azure version are notifications. So on premises, okay, when you are using, for example, the local cache to retain data in process, okay, you can get notified when an item changes in the distributed cache, okay? So you can basically use two invalidation policies. One is time-based and another one is based on notifications. The notification-based invalidation policies is at the moment unavailable on Azure because notification is not supported, okay? Finally, on Azure there is no default expiration policy. Okay, when you create a cache on premise, you can specify a default expiration period. This is not possible when you create a cache on Azure. Okay, so by default, the items will remain forever in your cache in Azure, but when you are using the API to put items in the cache, you can still specify a timeout. Okay, so you can do this using the API. So these are the objects that you are using in an application can be classified into three main categories. The first one is called activity data, and typically contains read-write data, which is related to individual users or sessions. So, for example, an ASP.NET session is an activity data. So, since you need to share the session across multiple machines in a scenario where your web application is running on a web farm, the session is a good candidate to be stored in the distributed cache. Another kind of data are reference data. The reference data are data that rarely change. They really change infrequently, like, for example, the items within the online, the catalog of an online store. Okay. And finally, there are resource data. Resource data are data that are shared across multiple users and multiple applications, and they change quite frequently. So they are not a good candidate for the distributed cache. Okay. So how it works? This is a code snippet to explain how you should use the caching API. So the first thing you have to do is to create the data cache factory. Okay. Behind the scene, the caching technology is using WCF when you have a client application that interacts with the distributed cache, the distributed cache runs as a Windows service. I'm talking of the on-premise version, of course. Okay. And your client application is talking to the distributed cache using WCF, and in particular the NetTCP binding. Okay. So when you create the data cache factory, indeed, behind the scene, you are creating a WCF proxy. Then you have to get a cache. Once again, on the on-premise version, you can create many caches with different names. In the cloud, you can just get the default cache. And then basically, you are using a pattern called cache aside pattern. That means you try to get an item from the cache, like in this case, a list of books based on the author. In this case, I'm using the author ID as the key to access the cache. If the books, in this case, are in the cache, I immediately return the list of books for that author. Otherwise, for example, create a proxy, I make a call, retrieve the books, I put the books in the cache, and I return the books. So this is in a few words, it means if the item is in the cache, I immediately return the item. Otherwise, I retrieve the item, I put the item in the cache, and then I return the item. So basically. So I just want to show you that on the on-premise version, you can administer the environment. Okay, wow. Let me do this way. Okay. Okay, you can basically administer the environment using PowerShell commandlets. Okay, so basically the first thing you have to do is import module distributed cache administration. The second thing you have to do is use cache cluster. Okay, and then you have to start the cluster. Like now I'm going probably to get an error because, of course, the cluster is already started. So I think it's start cache cluster. Yes, start cache cluster. But I get an error because it's already up. Okay, or you can download this utility from Codeplex that was written by a partner. So you can is available for free. And this provides a UI to do whatever you can do with the commandlets. And you can also see the log here, so of what you are doing, okay, with the interface. On Windows Azure, if you want to interact with if you want to use Windows Azure AppFabric caching, you have to access the management portal. You go to the service bus section, and of course, you need to create a namespace. Okay. Then when you create a namespace, you can also specify the cache. So you can create a cache. When you create, for example, new cache, you can basically decide the cache size. Okay. Now, okay, so let's say this is the scenario. Let's say that I have a WCF enabled application, and I don't want to rewrite or the entire code just because I want to inject caching capabilities. I cannot do that. So first of all, let's start from the server side. Let's say that I have a WCF service, an existing WCF service, and I want to use caching in such a way that when I receive a request, I want to see if the response is already in the distributed cache. If the response is in there, I want to immediately return the response from the cache without doing any call. So for example, on this slide, you see a client application that invokes a WCF service. The WCF service retrieves data from a backend database. In this case, you can just solve this problem in implementing a custom. Let me increase the size. So you can solve this problem creating a WCF extension. The WCF extension in question is a custom operation invoker. So as the name suggests, the operation invoker is the component in the WCF runtime which is responsible to invoke the method, okay, exposed by your service. You can create a custom component. So in this case, the custom operation invoker checks the presence of the response in the local cache or in the distributed cache. If it's in there, it immediately returns the response. Otherwise, okay, it makes a call using the default operation invoker provided by WCF, and on the way back, it caches the response in the cache, and then returns the response. So at the next time, okay, it will find the response in the cache. Of course, here, it's important the way you calculate the key. Okay, so we'll see that we can provide multiple ways to calculate the key of the item when you cache that item. Okay, so this is another scenario. Let me increase, okay. So in this case, I'm using exactly the same approach and the same component, but in a bespoke application. So in this case, I have a client application that submits a request through WCF to a bespoke application. In this case, I'm using the WCF custom adapter, and I will use an endpoint behavior to change the operation invoker, okay, to use a custom operation invoker. And once again, the operation invoker will check if the response is in the cache. If it's in there, it will immediately return the response without proceeding the call through bespoke. Otherwise, it will invoke bespoke. Bespoke will, the request will go through the orchestration, whatever, and on the way back, it will be cached. Okay. And the same applies on Azure. So I'm not going through these, but of course, this applies to any Azure hosted application. So if you have a web role or if you have a worker role, you can basically use the same approach. Like, for example, let's say you have a WCF service running in a web role, and this WCF service accesses data on SQL Azure to reduce the amount of accesses to SQL Azure. And in this case, it's not just to reduce, it's not just to speed up the application, but also to reduce the traffic against SQL and to reduce the cost, because you pay also for the bandwidth you consume on Azure. So in this case, you can use the distributed cache. So these are the features of the implementation. So I will show you at the end two different components, two different versions of this pattern. So Michael did an implementation of this pattern, and also a colleague of mine, Kristen Martinez, did the same. But they are exactly using the same technique, okay? And so, once again, in this case, it's very important how you calculate the key. So if the method is doesn't have any parameter, you can just simply use the action of the method, because of course it will always, it's sufficient to individuate the response. But if the method exposes multiple parameters, you have two options, basically. The first is you are using the entire XML as a key. This is very heavy, but sometimes it's necessary. But this doesn't work when the parameter list contains some parameters that they always vary, like datetime parameters. They vary from call to call, okay? In this case, it's much better to use another approach where you calculate the key based on specific parameters that you specify, okay, by position. Okay. So I just want to show you, since I have just half an hour, I'm not going to show you the demo, but I just want to show you the code. So this is the, so basically you have, you can inject the operation invoker, first of all, creating a custom service behavior. So within the apply dispatcher, let me increase the font size. Okay. So within the apply dispatcher, for each service endpoint, you are adding a custom operation behavior, and then in turn the operation behavior, okay, as you see, it injects, specify, it replaces it replaces the original invoker with a custom invoker. So if you switch and look at the code of this class, basically the code is very straightforward. It is not rocket science, and it behaves as you can imagine. I calculate a key based on the inputs using one of the methods you have seen before. Then you try to get the item from the cache. If the item is in the cache, I immediately return that value. Otherwise, the code just calls the original invoker, okay, to invoke the underlying service, and on the way back it caches the value and returns that value. So it's not complicated. And once again, if you are using this technique, you can transparently inject caching capabilities in your WCF service. You don't have to change anything, okay? Okay, just the configuration, of course. You need to change the configuration and use the service and specify the service behavior in the configuration of the WCF service. Okay, so client-side caching. This is interesting because this is not very commonly used. Let's say that last year, around January, I worked with a customer in the UK called Doug Robinson Group. They provide travel services, travel business services to their customers. They have a huge system which is largely based on BStock, and this system makes frequent calls against WCF and ASMX services exposed by many third parties. Okay, so since they have a huge amount of code, they wanted to have a mechanism to inject caching capabilities within their application, but on the client side. That means if their application makes a call to retrieve some data, and that data rarely change, and there is a high chance that that data will be reused, they want to cache that data, and they want to avoid to make the call because they pay these third parties per call. So there is no need to pay for, you, of course, for some data that you retrieved 5 minutes ago, okay? So immediately I realized that I could implement this pattern using, once again, WCF extensibilities. So in this case, as you will see, I resolved this problem by creating a custom channel. And the custom channel is doing exactly the same thing as the operation invoker. That is, the custom channel looks in the local cache or in the distributed cache, and if the data, if the response is in there, it immediately returns the response. Otherwise, it invokes the inner channel, and the inner channel will invoke all the channel stack through the transport channel. The transport channel will make the call against the underlying channel, and on the way back, once again, I will cache the response so that the next time that I receive a call with the same parameters and I calculate the same key, I will retrieve the response from the cache without making the call, okay? So, indeed, my component provides 3 different caching providers. So you can also use my component without using AppFabric caching. So the first provider is based on the memory cache object that was introduced by the framework 4.0. Many developers are unaware of these because this is a new class which is available just in the framework 4.0. The second provider is based on the web cache object provided by ASP.NET. Okay, so many of you, I'm pretty sure, know this object. And finally, the last provider that we are going to see in the demos today is based on, there are 2 flavors of this provider. One is using Windows Server AppFabric caching. The other one is using Windows Azure AppFabric caching. How can I use my custom channel? So first of all, you have 2 options. You can use a custom binding, and you specify my custom binding element as the first element of the custom binding. But I also provide you a way to use my custom channel with existing bindings. So in this case, you have to use a custom endpoint behavior. The endpoint behavior at runtime replaces the original binding with a custom binding containing exactly the same binding elements and injects my binding element at the top. So my binding element will be the first to execute at runtime, and it will create a channel at the top of the channel stack so that my custom channel is the first to execute. So once again, if the response is in the cache, I immediately return without calling the rest of the channel stack. So my component provides 5 key creation methods. So the first one is based on the action. Okay. Once again, you can use this only with methods without parameters. The second one is using the entire message body. The third is called simple. You can just specify, it generates this string, action P1, P2, Pn. The indexed one, you can specify is equal to the simple one, but you can specify which parameters you want to use. And finally, the last one, MD5, is using the MD5 algorithm. So this is the first scenario. I have a client application which invokes a WCF service, and the WCF service invokes another service. So this is a typical scenario where you have a scatter and getter pattern. So you invoke a service, and that service invokes many other services, and then collect all responses and generate a response. Okay. So in this case, as you can see, the pattern was this way. The client application invokes the service. The service creates a proxy. The proxy is using my custom channel. So once again, is using or a custom binding, or is using an existing WCF binding, but is using my endpoint behavior to inject the caching channel at the top. The caching channel at runtime checks the presence of the response in the cache. If it's in there, it immediately returns the result. Otherwise, the request goes down, it goes all the way down the channel stack to the transport channel. The transport channel sends the request message to the service. The service answers with a response. and the response gets cached by the caching channel on the way back. Okay. So let's see a demo. So first of all, I just want to show you that. So first of all, what you are seeing here is available on my blog and is available on the blog of my team. So because we have 20 minutes, so just in case, I just want to show you that this is, okay, so this is the article where you can download the server side by Christian Martinez. This is the article by Michael. This is Michael's version of the server-side caching. Instead, if you want to download my client-side caching component that I'm going to show you in a minute, you can go here on the Windows Azure Custom Advisory Team site. Okay, and there are two articles. There is the on-premise version, okay, and there is also the Azure version. And you can basically download the same from my personal blog, because here you have the Azure version and here the on-premise version. Okay, so let me show you the configuration. So first of all, to run the demo, I'm using a test project. So if we look at the configuration file of the test project, in order to compare the performance of an endpoint that always invokes the underlying service with another one that is using my caching channel, I created two different client endpoints. So the first one is using the basic HTTP binding and will always invoke the underlying service. Okay. And the underlying service in this case is a stupid WCF service that retrieves the titles of a certain author from the PubS database. Okay. The second one is using a custom binding. If we look at the configuration of this custom binding, you will see that I expose a very rich configuration capability. So first of all, you can enable the custom channel, or you can disable it. If you disable it, it will always invoke the underlying service, but you can eventually override this behavior on an operational level. Like you say, I don't want, in general, I don't want to use caching capabilities. I just want to use them for these specific methods. Okay, and here you can specify the action of the method. Okay, then you can specify which caching provider you want to use. I provide 3 different caching providers. Once again, one is based on AppFabric caching, the other one on memory cache, and the third on the web cache. In case you are using the AppFabric cache provider, you can specify a cache name or the region name and so forth. You can also specify a key creation method. In this case, I'm using simple or whatever else. And finally, I can also specify a timeout. So if you want your item in the cache to expire, after a while, you can specify a timeout. So if I can show you how it works. So I can debug through. So first of all, let me see. I clear the cache. Okay. So if I debug, I will make 2 calls using the same author ID. So the first time I won't find the item will not in the cache. So I will have to make the call and cache the response on the way back. And the second time I should find the item in the cache. Okay, so if I press F5, the first thing it happens is that it creates my binding. Oh, let me increase the font size. It will create my binding element. So this is the binding extension element that I have to use to register my component, for example, in the machine.config. This creates my binding, the binding element. So if I press F5, here is the constructor, which is, yeah, quite complicated. Then in my binding will create the binding, the channel factory, okay? Then the channel factory will create the channel. In this case, my channel implements the iRequest channel interface. The main method is the request method. So in the request method, I get the settings for a specific operation. Then I say, okay, I want to try to read the item from the cache. The first thing I have to do is to create the key. So here I have a method where I can choose between the different key creation methods. In this case, I'm using simple. So if I proceed, okay, and I choose a specific caching provider, in this case, I'm using the AppFabric cache provider. So when I press F5, the very first time I will create the data cache factory to access data in AppFabric caching. Cross my finger, okay. Then I call the get method. And the get method, the very first time, returns now because the item is not in the cache yet. So in this case, I want you to see what happens. In this case, if I press F5, here we go. I call the inner channel. So, you know, I let the request go down the channel stack. So this makes the call. On the way back, I write the item to the cache. So once again, I will use the AppFabric cache provider. In this case, I'm calling the add method that calls the put method of the caching API. And then I return the response. Okay. Now, this is the second call. I'm calling once again. So this time, I should be able to find the response in the cache. So if I go through and try to read, this time, the item is in the cache. So I'm not making any calls. I'm not going to call the underlying service, okay? So just to visualize the benefit in terms of performance, I also created some load tests. So in the first one, I'm always invoking the underlying service. I'm using the basic HTTP binding, no caching channel. So I always invoking the underlying channel. Let me say that this test doesn't make any sense because everything is running on my laptop. Of course, the service should be located on another machine to make more sense, okay? But still, this way, the difference is, you know, it's usually I am able to get nothing at the moment, okay? Let me see. I don't know what happened, okay? But usually the difference is it's around 30 calls per second, 25 calls per second. While when I'm using the caching channel, okay, with cache, see, I usually achieve something like 66 calls per second and so forth. Now I don't know what happened, so I just want to have the time to show you the demo that uses the Windows Azure. Okay, so let's proceed. We'll come back to these afterwards. I have just 10 minutes remaining. Okay, so you can use, of course, my custom channel also in a BizTalk application. In this case, you can use that on the same port. In this case, you have to use the WCF custom adapter, of course. This is another interesting scenario. Let's say you have an ASP.NET application running in the cloud that makes a call against a WCF service running on premise. First of all, from an integration perspective, you can use two different approaches. The first one is to use Windows Azure Connect. Okay, as John has said, Windows Azure Connect is a technology which is part of Windows Azure, which allows to create an IPsec protected IPv6 connection between an Azure role, so a VM role, web role, worker role running in the cloud, and your corporate network. So this allows an Azure role to access local resources like a file system, a line of business application, or a database. So for example, in this demo, I have an ASP.NET application which invokes a WCF service running on my laptop, and the WCF service, once again, is exactly the same, is retrieving data from a database. I have another demo where I have the same application retrieving data directly from the database. Okay. But you can also implement the same scenario, in this case using the service bus. Okay, so for example, you can expose, you can change the configuration of the WCF service to expose a service endpoint using the relay services. So this is exactly what I did. Okay, so I just want to show you, I cross my finger that everything works fine. So I created this application. If I directly invoke the WCF service, so in this case I'm using Windows Azure Connect. Okay, so the first time it takes, if it works, 10 seconds, 15 seconds. The very first time it takes time to establish the first connection. But then it's very fast if it works. Okay. Alarm. Okay, 8 seconds. But then it's faster. You know, it's half a second, and so forth. The second method is using the caching API explicitly. And once again, the first time it takes 3 seconds, for example, but then it's very fast. Also because I'm using the local cache. Okay. The third method is still using WCF, but is using a custom binding and is using my custom channel. So once again, the very first time I make the call, and then the rest of the time I will retrieve the data from the cache. I just want to show you that this is absolutely transparent to your code, because if I look at the code of this application, okay, this is the code of, this is the code that I use to invoke, to make the direct call. And this is the call that I use to invoke the method using my, now this is USB without caching, USB with caching, direct call, no cache, use WCF caching channel. As you can see, it's exactly the same code. The difference is the configuration of the client endpoint. So once again, if you go and look at the configuration, you will see that I'm using a custom binding. Now, what about if I'm invoking my service, but this time using the service bus and not using Windows Azure Connect? So if we look at the configuration of my service, okay, the service running on premise, wow, too much. Okay, exposes various endpoints. So it exposes two endpoints using the basic HTTP and NetTCP binding that, of course, you can invoke just on premises. And then it exposes two endpoints in the service bus. So as you can see, one using the basic HTTP relay binding and the other one using the NetTCP relay binding. Okay. How can I use my custom channel with an existing binding? Well, in that case, I can do the magic using a custom endpoint behavior. Okay, I show you the code. So basically, what I'm doing at runtime, let me see if I can show it to you, behaviors and endpoint behavior. Here we go. So this is the code. You can basically configure these for your WCF, and this is a general rule. I use this technique many times, okay, to inject. This is a common technique that you can use to inject binding element into existing bindings, okay. So basically, you are using the apply client behavior to get the list of the binding elements of the original binding. Then you can, create your own list. You can add binding elements. So in this case, I'm having the client cache binding element at the top. And then I create a custom binding. I make sure to copy all the properties of the original binding to the custom binding. And then I assign the collection of binding elements to my binding. Okay. So if we switch back to here, you will see that when I'm using my caching channel, I mean that the endpoint configured to use my caching channel is, it's 13 milliseconds, so it's very, very fast. Okay. So the last scenario, the very last scenario, it's becoming more and more common. It's a typical hybrid solution where I have two parties exchanging messages through the internet using the service bus. So in this case, I have, let's say, Fabricam sending orders to, I don't know the other name, I don't remember, the typical name of the Microsoft.
Contoso.
Contoso, yes. Sending a message to Contoso, and Contoso replies with something, okay? So, once again, you got the point. Instead of, sending messages continuously to retrieve the same, over and over again, the same information, I'm using my custom channel. So at this regard, I just want to show you the difference in performance. So if I let me see, I created 2 load tests, and hopefully if they work this time. So this is the first time it's not using my custom channel. So is in this case, every call passes through the service bus and invokes my service. So using this approach, I can get around, and in this case, I'm just using one thread. So if you go and look at the configuration of the load test, I'm just using one thread because I wanted to, to visualize this for a single thread. Okay, so this way I achieve 244 calls per second. Of course, if I'm using my caching channel, I can get much better results because I will make just one call, and the rest of the time I will retrieve the result from the cache. So this way I can achieve something like 60 messages per second with a negligible latency, like, I don't know, I don't even remember. So yes, usually it's around 50, 60, it depends. 36, going up, 44. 44. Anyway, I was not lucky this time. Okay, just to close, I have 1 minute. So this is just a resume of what we have seen so far. So when using the caching channel with the service bus, I can really achieve better results. But let me say so. Not only you can, when using the caching channel in the cloud, not only you can speed up your application, but you can also save money. Remember that, because you pay for all the messages you exchange through the service bus. Remember that. Maybe it depends on how many messages you exchange, of course. So once again, caching is part of our platform. I strongly recommend you to use both Windows Server Fabric caching for on-premises application and Windows Azure caching for your cloud applications. I just want to tell you that now we started the TAP program for the version 1.1 that will introduce some new capabilities. So, for example, you will be able to create providers that allows you to implement the write through and the write through the write behind the read through patterns. Okay, what does it mean? It means that when you write an item to the cache, you can create a provider that behind the scene takes the item and persists that to a store, to a persistent store like a SQL database. And the read-through patterns means that if the item is not in the cache, the provider will read that from the original store, from SQL, and will place it in the cache. Okay? And you can create your own providers. So we give you this possibility. Another interesting feature that you can expect in the future, especially for the Azure version, is a RESTful API. Because, of course, every services we provide in the cloud needs to be open to non-Microsoft technologies. So expect to see a REST API very soon to access items in the Azure cache. So I finished my presentation. That's all. I hope you find this interesting. And these are the references. You can go and retrieve the code and the articles. In my case, from my blog or from my team site, you can download Michael's code from it. This I don't know. Do you have another?
Another what?
Yeah, because this is still the previous.
No,
it's the same. Okay. Okay. Thank you.
Thank you very much.
Thank you.
Thank you.